Hello everyone, welcome to Electronically Connected. So in this video, we will be covering what an encoder is, what are the different types of encoders that we have, and we will be shedding some light on what a 4:2 encoder is, followed by what an octal to binary encoder looks like. So let's get started. An encoder is another one of our combinational logic block. Its function is just the opposite of what we have studied earlier, that is the decoder. So what an encoder has is, an encoder has 2n number of inputs. So it has more inputs and it has n number of outputs. So as the name defines, an encoder is basically used to encode something. So if we have more number of inputs and it gives us less number of outputs, that means a bigger thing, let's say something which has 8 bits. This gets encoded into something which is really small. And later on, this can again be decoded. So this can be fed into my decoder and it can again give out my output. So this whole process is used for encryption purposes, to transmit signals which are longer and we have a shorter distance to follow. So it can be broken down into a smaller thing, and smaller signal is easier to transmit, or it can be used for cryptography. So these type of encoders are used with a combination of decoders for transmission of data. Also, it can be used for implementation of different kind of Boolean expressions, which we will see ahead. So let me explain you how an encoder is matched with a decoder for the transmission of a data. So let's say we have an encoder. So we have more number of inputs. So we have set number of inputs. This is an 8:3 encoder. So we have 8 inputs and 3 outputs. So we have 3 outputs. And here we have a decoder. So we have again a 3:8 decoder. So this is my encoder and this is my decoder. Okay. So these 3 outputs of my encoder is connected as my inputs to my decoder, and we have 8 outputs. So let's just say we are inputting something at I5. This is my input. And what we get over here is my output 101, which represents 5 in binary. And this 101 is again fed to my decoder. And we get a 1 again here at I5. So this transmission of 1 from my encoder to my decoder is done, and a signal gets transmitted from one end to the other without the hazard of transmitting 8 signals altogether. So only 3 are transmitted, and it again picks up the output at I5. Now we have different types of encoders for different purposes of uses. So first we have a priority encoder. We will see what a priority encoder is in the next video. Next we have something called a decimal to a BCD encoder. Then we have an octal to binary encoder. And last, we have another one, which is the hexadecimal to a binary encoder. So all of these encoders are used to encode an input which is of more number of inputs. So we can, if we remember what an octal is, an octal has a base of 8. So that means 8 inputs to 2 inputs. So again, we are encoding an octal value to a binary form. Let us start with a simple 4:2 encoder. So again, here we can see that we have 4 inputs and 2 outputs. So let's draw the block. We have 4 inputs and 2 outputs. A1, A0 as my outputs. This is a 4:2 encoder, and my inputs are Y3, Y2, Y1 and Y0. Now let us see the truth table. So we have inputs Y2, Y1, Y0 and outputs A1 and A0. The truth table of an encoder is going to be the exact opposite of what we studied as a truth table of a decoder. So the output looks like an input. So we have 1, 1, 1 and 1. Everything else is 0. 0, 0, 0. So when Y0 is 1, the output combination we get is 0, 0. When Y1 is 1 and the rest of all the other inputs are 0, we have 0, 1. Similarly, when y2 is 1, we have 1, 0. And when y3 is 1 and all the other combination inputs are 0, then we have 1, 1. Let us see what are the equations now. So we have A1 is y3 plus y2 and A0 is y3 plus y1. And if you're familiar with the concept of minterms and maxterms, and you have seen the previous videos that we have discussed what a minterm and maxterms are, you will be able to identify that these are the forms of max terms. Now let us create the corresponding circuit diagram for these two equations. So we have two equations and we have a plus, so that means it's an OR gate. So we have two OR gates, one for each output. So we have A1 and A0. And here we have y3, y2 and y1. y0 is not reflected in the equations of A1 and A0, so we can leave it out. So we have our inputs y3, y2 and y1. Let's connect them. A1 is equal to y3 plus y2. So y3 and y2. And A0 is y3 plus y1. So we have y1 and we have here y3. And there we have it, the circuit diagram of a 4:2 encoder. Let's move on to another type of an encoder, which is called the octal to binary encoder. I know the name sounds scary, from octal to binary encoder, but it is actually just an 8:3 encoder. So if you have an 8:3 encoder, that means we have 8 inputs and 3 outputs. So A3, A2, A1 are my outputs and y7 to y0 are my inputs. This will give you a 8:3 encoder. That means 8 inputs for the 8 bits of an octal to a binary encoder. So let us see the truth table for it. So we have 8 inputs, y7, y6, y5, y4. So here we have the truth table of our octal to binary encoder with 8 inputs and 3 outputs with 8 combinations. Now let us see what will be the equation that can be formed for the outputs. So we have A2. So we have y7 plus y6 plus y5 plus y4. We can see A2 is 1 when y4, y5, y6 and y7 is 1. Similarly, A1 is 1 when y2 and y3 is 1 and y6 and y7. So that corresponds to y7 plus y6 plus y3 plus y2. And last, A0 is 1 at the alternate time. y7 plus y5 plus y3 plus y1. And remember, these are the max terms of our encoder. And remember, because we have 3 outputs, so we have 3 OR gates. So 3 OR gates will be used if we try to implement these equations using the circuit. With this, we come to the end of our video. In the next video, we will be discussing an important type of encoder, which is called the Priority Encoder. So thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.